It's not that powerful. I can make like all for example, this is all very important.
Okay. Okay. Hello. Hear me? Okay. This is the SdNOG 4 test. 1, 2, 3. 1, 2, 3. This is SdNOG 4. This AV. This AV complaining about the sound. Maybe.
You don't need to bend and talk to it. You don't need to bend. It's very powerful. It's picking everything that we're talking right now. It's will pick it. Don't do this.
Okay.
Just stand and speak.
Okay. This is SdNOG 4. Dean Tariq, heavy. AV. Checking the power cable. Doing things. This test is SdNOG 4. 1, 2, 3, 4, 5. AV is checking the equipment. Power. Good. Everything is good. But the air conditioner is not working. Air conditioner is not working. Okay.
Hey Abby. Is it nice? Okay. Okay. Louder. Okay. Hi Abby. I'm Abdush. How are you? Are you fine? I don't know what to say. Okay. 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 Ahmed. 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 مالك أحمد فيش حاجة تمام أوكي.
طيب السلام عليكم. هنبدأ بعد دقيقتين فقط. المفروض 2 minutes. السلام عليكم. بنقدم اعتذارنا ككوميتي بتاعت SdNOG على الايشو بتاعت الباور سبلاي دي. الكهرباء قطعت عموما كده، يعني عندنا تقريبا زي جدولة كده بتاعت قطاعات بتبدا دايما في الصيف، فالظاهر انها صادفت انها تبدا معانا هنا حاليا. فحاليا شغالين بيو بي اس، كل اي حاجه شغاله بيو بي اس. فاول ما الكهرباء تيجي حنقوم نعمل سويتشنج لليو بي اس، حنبدا تاني يعني تاني حتكون في فصله بتاعت ثواني كده وتاني نرجع لا من الكهرباء تجي. اذا الجدول اتظبطت معانا. اوكي. حنواصل السيشنز بتاعتنا. حنبدا اول سيشن بعد البريك حيكون with علي حسين. علي حسين is he's going to talk about cloud-based digital rights and rights management. Welcome to the stage. Ali Hussein is from Pakistan. He's doing his master's degree in Malaya at Kuala Lumpur. He is information security analyst and intern public policy researcher, and currently pursuing higher education, cloud computing, and governance technology at University of Malaya.
Bismillahirrahmanirrahim. Good afternoon, everyone. This is Ali Hussain from University of Malaya, and I will be talking about one of the key point in making internet a safer place, and it's about preserving the privacy of the digital contents over the internet. So this is the Okay, so fine. So my presentation will cover the role of private sector in privacy preserving, because when it's come to digital rights management, it is the it defines the mechanism to protect the digital contents, privacy, intellectual property rights of the on the internet. And in the cloud computing, because cloud is capturing a huge market in today's IT world, and a lot of our digital contents resides in the cloud. So in the cloud, the DRM is when some the data owner publish its content on the cloud, so it has to know how can it protect, how can it can enforce the access rights over its documents when the consumer of that that cloud, when the consumer access the devices, you can access from the mobile devices, laptop, and even now the smart devices, IoTs are capturing and consuming the cloud content, so it has a wide application. When it's come to the cloud development, it's only the private sector which contributes in the development of the cloud and defining the standards and the policies for the development. And in fact, the entire infrastructure is being as per the feedback and the work of the private sector. So they has to take care of the users' privacy into account, but mostly the corporate sectors are only concerned about their own business incentives, policies, and their own business interests. But in order to make the technologies more applicable and to grow increase their audience and to make their business work, they have to take care of the user's point of view, and they need to do a lot of things. So we will also be talking about why there is a need of particular cloud-based DRMs in detail, and the service delivery model of the cloud-based DRM, what are the solutions available, how is the architecture benchmarks, and how you among the IDEA, the academia, the IT professionals, or maybe the policymakers are gonna involved in this topic, and what are the potentials of you people can get benefit of this technology. And then of course the legal and the governance challenges associated with these sort of things. We cannot avoid these, because those are also essential in the fair use of the technology, and it's also really a matter of concern in the recent past few years, and the countries are being more and more active in developing their internet policies, cyber laws, and then we will also see some of the technological benchmarks, the available landscape in the digital rights management solutions, and some will be like takeaways for you as an audience to try some solutions out there and enjoy them. So privacy is concerned when the data is out in the internet, and some business owner is capturing data. Say for the telcos, they are storing the users' private information and their statistics about all that. Then the privacy became very much concerned, and it's on the responsibility on the private sector as well to. And in the private sector as well, to make sure the integrity of the data is intact, so that they have the trust of their customers, and people feel more relaxed and more confident on using the technology. So if we are not going to use or apply the DRM principles on the digital contents, it may have a threat to the data and the reputation of the organization, corporates. That's why it's very important to study these. Then when all the corporates and in the industry, they try to make the internet as much flexible and easy to use for the customers, and these sort of DRM mechanism are very much important so as to enable the more and more trust in their infrastructure, in the service delivery, and further, there is a lot of innovation going on in the IT sector, and startup culture is also going to up, and number of patents and publications are also growing very high, and it was not that much intense in the past few years, but the concern of privacy and the intellectual property remains if we do not adopt the DRM mechanisms, and this is a very crucial point, because this gonna kill the innovation and good ideas, good executions, if we are not gonna provide good solutions for protecting the intellectual properties and the privacy over the contents over the internet. Right now, there are majority of us use the many big services like Google, Facebook, WhatsApp, and we are also concerned about how these technologies are going to further support the innovation. So there has to be some mechanisms available to the customers to increase their to retain the innovations. And then the data movement and the competitiveness among, like when you there is always collaborations among the content providers to share their data with others as per their business model. So that thing has to also take care about the de-identification of the data. For example, some like organization collects the data, let's say from governmental organizations, so they has to de-identify the data. For example, there is personal information about everyone, so they have to reduce the data in a way that trim the information, public like personal information, so that data it does not reflect that you cannot trace someone based on data. Based on all the data, it has to be a generic information. Though there are a lot of applications in the academia and in the maybe the medical sector, so they want maybe the service governance improvements, but this has to be de-identified first, and so that people are like confident enough that their personal information not being misused. So we always talk, we have seen a lot of the network infrastructures, the DNS securities and all those solutions, the firewalls, etc. Those are just the network layer solutions, and in the application layer there is a lot of, I think, improvement. I think there is a gap which need to be addressed, like the content. The traditional security solutions are only concerned about the host to host or end host, but when it's come to the browser, the applications, or the WhatsApp or Facebook, there has to be some because they are also manipulating our data. So there is high need of having some DRM mechanism over there, so that our content on the application layer is protected as per our need. So it's come to very much more important when you are a business owner and you want to share your business information or business documents with other collaborators, maybe the customers. So what service you will be using? So I think for now majority of us use the Google Drive, or some maybe the Dropbox, or some very few corporates right now are using some some like private and secure mechanism to share and collaborate the document, but majority of us rely on the public and free available resources. And but there is, we will say later, that there are major concern but those publicly available solutions are not enough to protect their business. They are as per their business needs, so they are not as per our requirements. And all those solutions suffer from the traditional security landscape, like sniffing and all those password cracking and the hijacking sort of thing. So at the application layer, there has to be some need of an DRM mechanism. But in cloud it is more important, because the volume of the data is very high, and so is there are also big data applications on the cloud data, and this way that our in the cloud there has to specifically new standards, there has to define the new standards so that we protect the user's privacy and all those all these concerns we presented so far. There is a study by PwC that shows that they interviewed, I think, around 6,300 the corporates, and then they come up the data that the 36% of the current and the 27% of the previous employees are account for their data breaches, because it's not like they are intentionally, but it's maybe due to their they're unaware about the security challenges and how they are not trained well, how they can protect the IP of their company, and it's the stats shows that there is a high need that the employees need to be trained, and also there has to be some defined mechanism to control the access of the business critical business documents. So what the DRM solutions available? They have a different mechanism. They gonna transform. Let's say, for example, we study the case. You are gonna use some service. So how it gonna protect your digital rights? So it is, so for example, you gonna input. You want to protect your documents. It can be in PDF, it can be in PPT, it can be in any the document format. But the DRM software will first transform it to some standard file format. Transform it to some standard file format, and then it will be encrypted with some strong encryption. And this way they append all the necessary data, metadata, or some access mechanism, whatever they want to use. There is open research in this area. As for the academia, if you people are from the academia, there are a lot of ongoing research about what are the encryption mechanisms or the service delivery mechanism are to be used so that the content is protected well, and also to increase the user's experience, because when on the cloud there are the mobile devices which has limited battery, limited processing, limited storage. So these benchmarks, the performance benchmark has to be kept in the mind while developing these solutions. So there are a lot of research opportunities in this, and for the IT security guys, there is some like hope that even if your data is breached, if your organization is breached, so there is an extra layer of security on your critical infrastructures. So it is gonna protect the IP and all those critical documents or some contents maybe online. So this can be seen as a next second firewall on your contents only. So even if some some like the malicious intended guy intruded in your network and it steal the information and steal the files from your like this network, then it is encoded as it is a custom encoded, so it won't be able, he won't be able to decode it, and that's why that's where this wall will take into play its role and will protect your the business documents. And one thing more is these writes are like offline writes, sort of offline writes. So they are gonna stick with the file even if the file travels via USB or via email, whatever. So there's they because it's offline intact metadata inside the file and the file itself is encrypted. So there's no way that unauthorized person can open it. Even if they got the same software, the license will not allow it to open the file. These are some of the features in the ownership, what you can assign. So for example, you are a data owner, you are a file owner, and you want to, let's say the CEO, you got all the rights of viewing, editing, sharing, deleting, print, and then you want to share with your project managers. So project manager, you can select based on your requirement. You can in this scenario it doesn't allow the managers to delete and forward, and then the editors or maybe the developers only concerned with view and editing the company policies. So and then the readers, maybe the sales team, so they can only view all the documents. So these sort of useful applications you can apply on the document. And by the way, these are not available in all the publicly available repositories like Google Drive, OneDrive, Microsoft OneDrive, and there's Dropbox. So this is where this new technology come into play to protect customer use. So their delivery mechanism is pretty straightforward. There are some license servers across their. Let's go next slide so we can better understand the scenarios. So we are here. As a consumer, we can access from our own network, but when it's come to publishing that content, the content provider will publish on the content server, and then its corresponding metadata will be automatically created based on that content. So after that, based on the content providers, there will be license assigned to that content. For example, the picture, and that will be stored in then different device. So all the licenses and access are different than the content itself. Then when the requests are to be made for the content, then it will be validated by first the licenses, and then the content will be delivered to the user. So DRM and law and internet governance, I think it's very much important to discuss. Right now, there are many countries in which do not have a proper digital rights laws, and specifically for the cloud, I think there is a need to do a specific legislation in these. Taiwan is a very good example because they incorporated comprehensive privacy protection laws in which they take into account the role of the government, and they try to define the role of the government as well as the private sectors to like the global consensus on the role of what is the privacy from the government's point of view, because they want to see every person, and what is the role of the user itself and the corporates, how up to what extent they can use the data, and what thing if they want to share with other departments and the same data, they has to follow some SOPs or all those security checks. So there is high need that the government itself should take into account, or should overlook all these issues, and has to propose the solutions to like govern all these legislations and complete all this. I attended last month I attended APRIGF 2017, and there was So let me quickly sum up my presentation. So what are the there are already some solutions available in the market. So Microsoft PlayReady is a cloud-based digital rights platform, but they are very special as I stated earlier. They are as per their own business needs, and it's only concerned with the video content and some of the limited file types. And then the Google Widevine is a Google multi-platform, but it's only supported in the video streaming only in the browsers, and that has a very limited support. And Apple Fairplay is also in digital rights enforcement for the streaming, but it's only supported in the Mac. But there is an interesting project in the market, which is free for use for limited storage. You people can try this. This is SkyDRM. You can sign up. You get some 1 GB space to try it out. So over there you see three repositories. So we already use many of, I think all of us use the Google Drive and the Dropbox and OneDrive. So it has a capability to import. When you sign up, you are going to add your own repository and into this, and then you can assign directly the rights to your documents available in the G Drive. So after adding the documents from your account, you can see who can access when you're going to share that document with others. So you're going to see all those events, who just opened it, who just edited, who is going to like do whatever and can enforce extra security improvements in your online content. So but it's only document supported on all the browser, and this is a very good thing. You people can try this. So and I think this is a worth trying thing. And then finally the volume. This DRM market in the 2015 was about 1,000 million USD, and now in the 2020 it is expected to grow in 2898. And by the way, the previous company, the previous quarter, from the past 4 months, their sales are expecting 4 times more than than their expectation. So this technology is being rarely being adopted in the industry as well. And finally, there has to be some safe mechanism when the data travels from the one cloud provider to another cloud provider, and companies. This is basically if companies for this DRM enforcement, you don't need any critical physical infrastructure. It's just protecting on the application layer data. So it has nominal cost of implementing this, and then by this you will have more control on the technology, and security and privacy are major concern that impact global cloud adoption as well, and this has to be implemented as soon as possible. So any questions? Sorry. Thank you very much.
Thank you, Mr. Ali. Our next session will be with all attendee working from Nigeria. He's working as a trainer at Afrinic. He's going to talk about Introduction to Software Defined Network, SDN, using OpenFlow. Welcome to the stage.
Good afternoon, everybody. Good afternoon to the warm people of Sudan. I'm very happy and honored to be here again today. Now, for the people who have seen me, interacted with me for the past 3 days, they will notice that I'm a preacher. Yes, I preach the gospel of technologies that are old enough to be in Africa, but they are not in Africa yet. I just finished a 3-day session with IPv6. IPv6 is 22 years old, and there's next to nothing in Africa. Today, I'm going to give you a crash course in a technology that turns 10 years old next year, with the hope that I'm going to sow a seed into your hearts and we'll start growing this technology on this continent. Now, there are many buzzwords around in network computing, software-defined networks, network functions virtualization, VXLAN, and so many things. This session, I'm trying to clear the smoke very quickly because we don't have that much time on software-defined networks using OpenFlow. And part of this session, I intended to show you a demo of what I've done, a little work on SDN, but because of time, we can't do that here now. But after the session, please feel free to come and see me, and I will talk about it. Is that working? Happy. Okay. So this is the agenda. Let's just quickly go through this. So, like I said earlier on, as network engineers, we should embrace every technology that comes into the niche that we operate. Okay? Okay. Into the niche of every technology that operates in our niche, we should embrace it. Not that because we just know IPv4 or we know how to configure OSPF on Cisco routers or something. Embrace every technology. Now, this technology, software-defined networks, is a complete paradigm shift. It's a different way of networking entirely. Okay? Just like IPv6 is a different way of IP addressing. So, like I said earlier on, we'll be looking at the fundamental concepts behind software-defined networks. So, legacy network architectures. What do you know? I mean, what we know about today? We have this kind of devices. Sorry. Where we have our control plane, the data plane, the manager's plane, all incorporated into a single device. That's not funny. Okay, all incorporated into a single device, which inherently makes these devices very, very complicated, believe it or not. Okay? And also again, moving forward with the legacy architecture we know, it employs a sort of distributed computing model where each node on the network has its own control plane, its own forwarding plane, basically its own control plane. Where, for example, like OSPF, you run your SPF on a single router, it sends updates to other routers, and they have to do the same thing. So it's a distributed computing model. Okay? So two things. Everything incorporated into one device, and then you have a distributed computing model. Now, what are the challenges that we face within the current legacy network architectures we have? Scalability, that's why we have multi-area OSPF already. Technically, security issues also plague SDNs, but we have it here in legacy network architectures. Then we have limitations by vendor locked-in. So, well, thank goodness, Cisco eventually revealed or opened up EIGRP as an RFC last year. Well, typically you have different vendors implementing different technologies in their own way, and you're locked to that specific vendor if you have their device on your own network. Okay? It's not open, it's closed. Network management. So if you want to configure like 20 routers or whatever, even with your Ansible or whatever, it's still error prone. A lot of human error can still come into it. Okay? And then finally, I said innate complexities, which I will shed more light on as we move on. So, what is software-defined networks? Like I said earlier, it's a paradigm shift. It's a completely different way of networking. It's a different architecture. And what is this architecture like? You basically decouple the control plane from a network device and put it on a centralized computer or server. And then you have just the forwarding planes on your network. With this style or this architecture, you have a centralized control plane. Okay? And next to dumb forwarding planes on your network. As compared to the distributed model you have, or we have in these legacy architectures we run mostly on our networks today. So, this is the SDN architecture. Basically, you have the control layer here, which is the network controller, the one in the middle here. That is the one that is centralized. You have multiple forwarding planes all over your network, which don't have any compute or minimal compute. And then you have the upper layer on the controller, where you have different not-bound APIs that you can use to program your network or program your data forwarding planes on your network. The controller also gives you, presents a southbound API, which is the most popular one now, which I'm going to use today, is OpenFlow. You can use other protocols. You can even use BGP. There's another one called OpenVSwitch database. They're different. But OpenFlow is the most common. And to explore that illustration again, this is the SDN architecture, where you have, I've put a line here for you to show the demarcation. This is the control plane, and this is the data plane, which is these three switches here are data planes. You have the network controller, which gives you OpenFlow as a southbound API, and you have a network operating system, which represents a northbound API. In most cases, it's a REST. Most controllers implement a REST API, but this is not a very standard. This is not a defined standard yet. So we have different northbound APIs, but OpenFlow itself is the standard already for the southbound API. And I want you to take note of these two arrows, the packet out and packet in. This is with respect to the controller. So if you look at Wireshark captures between an OpenFlow switch and the controller, you will see a packet in, packet out packets, and they all have different functions, which we'll look at briefly today. Now, this is slightly different. Like I said, my job is to preach technologies that are old enough to be here, but are not here yet. All these big guys have already adopted OpenFlow or software-defined networks in one way or the other. Okay? Juniper, Cisco, Oracle, BT, an ISP, big ISP there in the UK, Orange, all of them. Now, pictorially, look at us. SDN. Although Asia too is not doing too good. So we have North America and the rest of the world. So I am trying to sensitize us with this technology. Now, what is the advantage of the SDN approach? Like I said earlier on, that's central, the first item there, centralized management. You have one point where you manage your network. You don't have to telnet or SSH to different devices to manage your devices, your network. And that also reduces your error in configurations. It's less error prone. Loop avoidance at layer 2. So basically, if you don't have layer 3 switches, you are at the mercy of spanning tree. So if you build if you see networking 101, you build your network with access, distribution, and core, STP will block links all over the place. And you might be using just one part of your network, which reduces your bisectional bandwidth. But with SDN, and no controllers, Floodlight, for example, or Open Daylight, they will do shortest path forwarding at layer 2. There's a new technology now, I think it's Trails. You have to use routing bridges to do that at layer 2. And like I said, this adds more complexity to the whole picture. All right? So network virtualization, you can do network sharing, infrastructure sharing easily with an SDN controller or SDN implementation. And there's also a cost benefit to it. Like I said, you don't have your forwarding planes are somewhat dumb switches now. They have minimal compute. They are just bare metal switches. They are quite affordable. They're not a high-end switch with all the new features, all the bells and whistles blowing on it. No. Okay? And then finally, this is says dedicated channel for controlled traffic. Although research has shown that to an extent, SDN generates a lot more controlled traffic than you have with your legacy networks. And then challenges facing SDN, latency, number one. You will see later on that for every new packet that comes to a switch, and the switch doesn't know about it, it has to forward it to the controller, and the controller has to take a decision. That will introduce some latency. Okay, controller switch latency also, it's there, okay, because the control plane is another machine. It's not within the same box. The TCAM tables, which your flow tables in OpenFlow switches use, are power hungry and relatively expensive, more expensive than what you use in your MAC address tables. Scalability, how many switches can a single controller handle? You have to look at that. Redundancy, well, with OpenFlow version 3, that has been corrected, where you can have multiple controllers connecting to the same switch, because once the controller dies, what happens to the switch? It has no brain anymore, okay? And then security, because a controller is usually running on a machine, on a server, for example. So you can do a denial of service attack on a controller, and it might not be able to do anything to your switches anymore on your network. You're stuck. And then the level of awareness, which is where I'm here, and the skill set. Fact, most of us network engineers don't like programming. Am I right? Yes, we don't like it. But we've been forced to like it, because you need to program if you're going to do SDN. Okay? All that programming you do, configure terminal on your Cisco devices, it's a cake. Okay? So the learning curve is a bit steep. Okay? So what are controllers? Network control, OpenFlow controllers or SDN controllers provide a central place for management. The controller has the full view of the network. That includes the switches, the links, and the end nodes, servers, clients, all over the place. Okay? And like I showed in the diagram earlier on, it gives you, it presents you a northbound API for you to program your switches, and a southbound API, which is OpenFlow, which actually manipulates the flow tables on OpenFlow switches. So basically, like the demo I was going to show you, because you actually exchange different packets between OpenFlow controllers and OpenFlow switches. The one I used in my application had to do with the network traffic. It's for traffic engineering. OpenFlow presents port statistics, okay, between a switch, traffic flow into a switch to a controller. You can use this information to, for your own use. Program something, usually it has to do with QoS or traffic engineering, okay? So how does, I just said it now, the controller has the entire view of the network. How does it achieve this? It's not magic. It's LLDP, which we all know. We all know what LLDP is, right? Link, layer, discovery, protocol. Yep. So each OpenFlow compliant switch uses LDP, which is sent to the controller, and the controller uses that to build the network of switches. It is when hosts start communicating that the controller starts to build, the view of nodes on the network also. Okay? So these are different controllers on the market now. It's a bit small, I know, I'm sorry. The one I used was Ryu because it's written in Python, which is very simple, and I could find my way around it. A very good one, which is a lot of big players are working on it right now, is Open Daylight. Okay? That is very big, but I got lost in it. So I'm using Ryu. And you can see this OpenStack. Are we all familiar with OpenStack? OpenStack integration with Ryu and to some extent with OpenStack, with Open Daylight now. Okay? So you can see you can integrate SDN into your cloud environments also. Now they're saying OpenFlow. Now OpenFlow, like I said, is the standard or the most popular southbound API which SDNs use. So it's basically if a controller wants to send instruction set to the forwarding planes, or the control plane wants to send instruction set to the forwarding planes, it uses the OpenFlow protocol. And it runs by default on TCP port 655 actually. 63 is now legacy. 6653 is the IANA assigned port now. Okay? So we have different types of OpenFlow to control OpenFlow messages. We have the controller to switch, which is usually sent by the controller to the switch, and that will be a packet out message, as you saw in the diagram. And then you have the asynchronous messages, which could be sent either way without any event triggered. And then we have symmetric also, that is sent by either a switch or a controller. So this is also very small. This is a controller to switch message here, which is a feature request. The controller is asking the switch for a request, for its features, requesting for its features. And that's how the controller builds the network with the capabilities of the different devices on the network. This is also, this is actually supposed to be a controller to switch, I'm sorry. It's also a packet out message. And this is an asynchronous message. This particular packet is it's a packet in, and it's sent by a switch to the controller. And why is this? This is because the first packet arrived at the switch did not know what to do with it, and it sent the entire packet. You can see why I said some of the control traffic in SDN is a bit much more. This is the entire packet of the first flow sent to the controller. Okay, so you also have some unsolicited messages. So hello, just like you have in routing protocols, I want to know if my controller is still there or not. Okay. OpenFlow switches. Okay, so you have different types. Actually, you have the pure OpenFlow switches. You have the hybrid switches which run both OpenFlow and run the legacy way. And basically, they perform the function of rewriting headers of a packet that arrives at the switch. Or, if it doesn't know what to do with it, send it to the controller. Now, in an OpenFlow switch, as you've seen on the graphic later on, you have both a MAC address table and a flow table. Okay? Because in software-defined networks, we forward traffic based on flows, not destination-based forwarding. Okay? So you have different OpenFlow compliant switches. I know HP for sure. So this is the flow paradigm. Like I said, this, for example, when you have a port and a destination MAC, that is switching. Okay, that's simple switching. You have a port, you have a destination MAC also here. You have a firewall. Now, with flow switching, you can use any of the headers, any of the fields in the header for taking any action on the packet. Okay. The most basic one is to be the import. If it comes into this port and is going to this destination, do that with it. Okay? It's not just destination-based forwarding. This is the flow switching paradigm. Now, a bit small, but this is the logic behind it. So when you have a packet comes in, the switch passes the headers. If there's any instruction in the flow table, it acts on it, it takes the actions on it. If there's not, it forwards it to the controller. So topology discovery, I will quickly do this quickly. Have a little time. So this is a simple SDN network where we have the switch here has a MAC address table and a flow table which is empty. Now A wants to communicate with B. A sends an ARP request. It gets to the switch. The switch does not know where B is. Okay, and ideally what happens in our legacy architecture? Flood all over the place. Okay, so what does the switch do? Well, the switch knows now that A is connected to this port. That goes into the MAC address table. What does the switch do? The switch sends a packet in to the controller with that ARP packet. Okay? And what does the controller do? The controller sends the packet out and tells the switch to flood. See where the latency comes into play? Although it's very fast. Okay? But now the controller knows where A is. See how the controller builds up nodes? And then he floods. Switch B, again, does not know what to do with that because B hasn't communicated yet. What does he do also? He sends a packet into the controller. What does the controller tell him? The controller tells him to flood. Okay? And when he does that, B receives the ARP request. And when B replies, what does he do again? Ask the controller. But this time around, because the controller knows where A and B is, she's going to, there's a particular open flow message called the flow modification. The controller uses that to program the flow table of the device. Now, here you have the flow table, which is a bit in small print, but it has an action, an input source and destination, and an action. Okay, it's different entirely from a MAC address table. So you use different fields in your header to make a decision of forwarding. And this basically unifies the functions of a device. So your switch, your dumb switch in your network, based on what you do, can be a firewall, it can be a router, it can be a normal switch, if you're using a flow approach. Okay? Because you have access to all the headers, fields in the header. So also, I'll quickly go through this. In response, because they don't know what to do, they're going to ask the controller again, but the controller has to program. Remember, the flow is only in one direction. You have to program the return path also. Okay, and this is where the controller programs the return path. Now, like I said, I was going to show a demo, but if you please feel free to see me after this session. You'll find me where there's food, or tomorrow I'll be here all day, okay, doing nothing. So you can come and see me. So like I said, in my own demo, I use the Ryu OpenFlow controller because it's written in Python, and I was able to find my way around easily. I said it earlier on, it's a bit of a steep learning curve, but with a lot of interest, you will find your way. I put a link also to the files, the code, because actually I modified there's a switch class and a traffic monitor class. If you're interested, if you want to see it, I put a link to where you can download the files. Now, basically what the application does, because if I had shown the demo, it would have shown you this kind of output. Every flow that goes on the network, it gets the throughput of that flow and the packet loss. Okay, now this I was going to implement on a small enterprise network where, like I said, in OpenFlow or in software-defined networks, you have shortest path forwarding at layer 2. Okay, so let's say on my access distribution and core, all implemented with multiple links all over the place, like cobwebs. If I see that this particular link or this particular flow is hogging all the bandwidth on this link, I can redirect it to less utilized links on the same infrastructure automatically. Okay. All right. So this is the general idea behind this particular application, which was written on the controller, and the switches don't have any form of control logic in them. Okay, all you have to do is once the flow gets into them, they inform the controller, and I get all the necessary parameters to know. Periodically to query that switch to know the throughput of that particular flow and if it's violating or it's overutilizing that link or getting that link. Okay, so that was the sample. That was the demo topology, which I was going to run different flows all over the place. So, like I said, you can simulate it for that. Thank you very much. Sorry, I was a bit quick. Any questions? Yes, please.
Thank you for your active topic, really characteristic so much. But I want to know what is the maintenance problem you usually approach? You talk about the advantages and also you talk about the challenges, but you don't put the light on the maintenance problem. If some router is crashed, if the network needs to be developed or something like this. That was the maintenance.
The maintenance.
Good and the advantages or the challenges. Thank you so much.
Okay. Well, based on my experience, you usually don't have any challenges at the switch end, but at the controller end, yes, you might have encounter several challenges because at least I worked with open source controllers, so you might experience something like an application closing unexpectedly, just like that, without you, without any warning whatsoever, or consistent memory use on the server by controller. So usually, like I asked the question earlier on, we don't like programming. We don't like programming. If you look at the beginning of this slide, we have two, myself and another guy. He's a system admin in Afrinic. He actually rewrote my very dirty code for this particular application. So probably, to the best of my knowledge, you have issues at the controller end, not at the switch end. And it still boils down to that steep learning curve. Okay? Are you okay? Thank you. Any other question, please?
I would like to thank you on your great presentation and the guidance of this technology. I would like to ask if there is any kind of simulator application or something to the community.
Yes. Actually, one mistake I made, because the demo I have is actually I implemented it on the VirtualBox. I could have created an image of that and give you guys a link to download it and run your, I'll do that, but I don't know how to get your contacts. But Mininet is a very popular tool for simulating or emulating software-defined networks, particularly in research. I used to work in a university, and that's what I used. Most of the SDN controllers are open source. Reuse, I can show you the documentation pages, well documented. It's all over the place. Open Daylight even, it's open source, despite the fact that Cisco, big giants are working on it. It's all open source. So the tools are there for you to play with. If you have the bandwidth to download, I'll give it to you. All right, thank you. I should get up a bit.
Thank you Torangi from Afrinic. Now طيب حاليا المفروض البريك بتاع اللانش عن الصلاة فنشوفكم بعد 40 دقيقة بالضبط فقط. اوكي؟ حاجة